So today we are going to discuss about electric charges and fields. So this is an important topic from which question may be asked from for your ESSEC 2023. So today we are going to discuss about this. So electrostatic deals with the study of the force, fields and potential which may arise from the static charges. So electric charge is the property of protons and electrons which give rises to electric force between them, and hence this is known as the electric charges. And the like charges repel each other while unlike charges attract each other. When a charged body is brought in contact with earth, all the excess charge on a body disappears, causing momentary current to pass through it to the ground, and this process is known as earthing. So there are certain basic properties of electric charges. So these are additivity of charges, that is the total electric charges on an object is equal to the algebraic sum of all the electric charges that are distributed on different parts of the object. For example, if a system contains of n charge, that is q1, q2, q3, then the total charge on the system will be equal to q1 plus q2 plus q3 up to qn. For example, the total charge on a system containing 5 charges, that is plus 1, plus 2, minus 3, plus 4, minus 5, then the total charge will become minus 1. The charges is conserved. When an isolated system consists of many charged bodies within it, due to the interaction among these bodies, charge may get redistributed. It is found that the total charge of the isolated system is always conserved. So the charge is neither created nor destroyed. Quantization of the charge. The fact that all electric charges is always integral multiple of E is termed as the quantization of charge. That is, Q is equal to Ne, where E is equal to 1.6 into 10 to the power minus 19. Here we have a question that is asked in the previous year. So a charged body contains a charge Q is equal to 0.8 into 10 to the power minus 19 coulomb. So is it possible to have such a charge? Give reason. The answer is that it is not possible to contain a body that is having a charge Q is equal to 0.8 into 10 to the power minus 19, because for having a charge, any body needs to have a charge that is a basic multiple of basic charge, that is 1.6 into 10 to the power minus 19. So it is not an integral multiple of 1.6 into 10 to the power minus 19. So it is not possible to have this charge. Next question we have, is there a variation of mass in the charged body? The charging involves the loss or gain of electrons which has mass. So mass of a body decreases on positively charging and increases due to negatively charging. So yes, there is a variation of mass while a body is charged. Next we have an important question. A polythene piece is wrapped with wool and it is found to have a negative charge of 3 into 10 to the power minus 7 coulomb. So for doing this, we will be using Q is equal to Ne, and we know the basic elementary charge, that is 1.6 into 10 to the power minus 19, and the value of Q is given 3 into 10 to the power minus 7. So we can find out the value of N, that is 1.8. So the value of N will be 1.87 into 10 to the power 12. So in this video I am trying to discuss about all this question that may be asked from electrostatics and electricity. electrostatics mostly. So here we have electrostatic induction, the temporary electrification of a conductor when such body is brought near to it is known as electrostatic induction. So this is also a question that is asked in previous year. Write the SI unit of electric permittivity. So it will be farad per meter or C square divided by Newton per meter square. Next we have what is an electric dipole. So it is a pair of equal and opposite charges plus q and minus q that are separated by a distance of 2a. Write down the dimension of resistance. It will be ml square t to the power minus 3 I to the power minus 2. Next we have a question that is a 900 picofarad capacitor is charged by 100 volt battery. How much electrostatic energy is stored by the capacitor? So the total electrostatic stored by capacitor is given by half Cv square. So we are going to place the value of C here. So C is given to be 900 picofarad. So pico means 10 to the power minus 12. So we are writing 900 into 10 to the power minus 12. And V square, where V we have 100 volt, it will be 100 multiplied by 100, as it is V square. So we will have 100 multiplied by 100. So calculating this, we will get 4.5 into 10 to the power minus 6 joule. So this is the answer to this question. Next, there are also several questions that are asked from this chapter. Next, we have these two numericals that are asked from this chapter. Calculate the magnitude of electron. Just check the question. Now I am going to answer it. F is equal to this is the equation of force. So we have this value as 9 into 10 power 9 multiplied with q1 and q2. Here both are having the same charge, so it is square divided by r square, and r is 0.5 Armstrong. Armstrong means 10 to the power minus 10. So we have 0.5 into 10 to the power minus 10 the whole square. So calculating this, the value you will find out is 92.16 into 10 to the power minus 9 Newton. Next we have another important question. This is the question, and we will have to find out a plane that is parallel to YZ plane. So here E, we have the value of E. Similarly, through a square of 10 centimeter, so area of the square will be 10 centimeter square. That is, if we try to convert 10 centimeter into meter, we will get 0.1 meter, and squaring this we will have 0.101 meter square. Now if we want to calculate the electric flux through the space, we know flux phi is equal to E vector dot del S vector, that is the area. This is the area and this is the electric field. So we have the value of electric field given here. So we are writing this value multiplied with del S, that is the area, 0.01 meter square. So calculating this we will get 30 Newton meter square per coulomb. Next we have also this question, state the Coulomb's law and write its vector form. So this is an easy question, so you can just look at it. Okay, so 3 condenser is of capacity 3 microfarad are arranged in such a way that the equivalent capacity is 2 microfarad. So you need to draw this arrangement. So this arrangement will look like this. In case of capacitor, these two are, and though these two are parallel, so we need to calculate this 3 plus 3, that will be 6 microfarad, and these two are in series. These two will be in parallel and this one will be in series. So 6 and this one is 3, that is we can find out the equivalent capacitance by 6 into 3, that is 18, divided by 6 plus 3, that is 9, or we will get 2. So this is 2 microfarad. Another important question that comes from this is the state and prove the Gauss theorem of electrostatics. So you can just check the answer. So this you might know it. And another important, apply Gauss theorem to calculate the electric field due to an infinite plane of charge. So this one will come out to be. So this is the answer. Also another important question that comes from this is, deduce the expression for electrostatic potential due to a point charge. It has also been asked in the previous year. So you can find out this answer. It is given in your book. So if you derive this will be the answer that you will obtain. This is another important question where you are asked to find out the potential. So V is equal to 1 by 4 pi epsilon naught Q into R, Q divided by R. This is the expression for the potential. So you are given the charge Q, and you are also given the distance, that is 9 centimeter away. 9 centimeter, if you convert it into meter, it will be 0.09 meter. So if you place the value of 1 4 by 4 pi epsilon naught, that will come out 9 into 10 power 9, and the value of Q, this one you are placing it, divided by R, that is 9 centimeter, converting into meter, you will get the potential. Okay, after finding the potential, you need to find the work, and this work will be equal to Q multiplied with V, that is this one will be multiplied with the potential that you are, work will be Q multiplied with V. This is the V, and this will be multiplied with the charge Q. This one is the charge Q. So Q multiplied with V, you will obtain 8 into 10 power minus 5 joule. And no work done will be path independent. So this is another important question in which we need to calculate the electric flux. A point charge of plus 8.85 into 10 to the power minus 7 coulomb is situated at the center of a cube of side 1 meter. Calculate the electric flux through the surface of the cube. So electric flux, that is phi, will be equal to Q by epsilon naught. So we have the value of Q to be 8.85 into 10 to the power minus 7 divided by epsilon naught, that is 8.85 into 10 to the power 12 minus 12. So we can obtain this value to be 10 to the power 5. Next we have another important question, differentiate between mass and charge. The mass of a body is always positive, while a charge can be either positive or negative. For example, the total charge of a system containing 5 charges is can also be minus 1, but mass of a body cannot be negative. Questions are always asked about the basic properties of electric charge, so you need to read them. This is another year's question paper, so here also it is asked about the Gauss law, so you need to know about the Gauss law. Next, another important question, a pair of charges plus Q and minus Q are separated by a small distance 2a placed at an electric field E. So the line joining the charges makes an angle theta with E. Write the expression for torque and also find the magnitude of torque. So magnitude of torque will be QE into 2a sin theta. So multiplying this we will get 2QA E sin theta, or torque will be equal to P cross E. Next, another important question is asked, which experiment established the fact that electric charge is quantized? So its answer will be Millikan's oil drop experiment. So this is another important question. Here also it is asked.